If you like compact theorem decks like this, subscribe, because today we are doing a quick sweep through 15 ellipse facts worth knowing on sight. Ellipses look softer than circles, but the geometry is deeper. You get foci, tangents, directrices, projection, and some beautiful algebra packed into one curve. We will go one by one. For each card, I will say what to spot, what the fact says, and one sharp proof hint. Number 1 out of 15. Standard form. The basic ellipse equation is x squared over a squared plus y squared over b squared equals 1. Proof hint. Start from a circle and scale the axis differently, or derive it from coordinates. Number 2 out of 15. Focus triangle relation. The center, one focus, and one co-vertex make a right triangle, so c squared equals a squared minus b squared. Proof hint. It is just Pythagoras on that built-in ellipse triangle. Number 3 out of 15. Eccentricity. The eccentricity is E equals C over A, and for an ellipse, it stays below 1. Proof hint. Use C squared equals A squared minus B squared, so C is strictly smaller than A. Number 4 out of 15. Constant focal sum. From any point on the ellipse, the two focal distances add to 2a. Proof hint. This is the rope and pin definition, and reflection gives a clean geometric explanation too. Number 5 out of 15. Directrix ratio. Distance to a focus is E times distance to the matching directrix. Proof hint. Write the point in coordinates and compare the two distances directly. Number 6 out of 15. Tangent reflection law. The tangent makes equal outside angles with the two focal rays. Proof hint. Reflect one focus across the tangent, then use the focal sum extremal path idea. Number 7 out of 15. Normal bisects the inner focal angle. The normal splits the inside angle between the two focal segments. Proof hint. Once the tangent makes equal outer angles, the perpendicular normal becomes the inner bisector. Number 8 out of 15. Focal split by x. The two focal distances split as r1 equals a plus ex and r2 equals a minus ex. Proof hint. Combine the constant focal sum with the coordinate difference coming from the focus offset. Number 9 out of 15. Focus polar law. Measured from one focus, r equals b squared over a minus c cosine theta. Proof hint. Substitute x equals r cosine theta into the ellipse relation and solve for r. Number 10 out of 15. Tangent equation. At one point, x0, y0, the tangent is xx0 over a squared plus yy0 over b squared equals 1. Proof hint. Plug a moving line through the contact point into the quadratic and force a double root. Number 11 out of 15. Auxiliary circle projection. Circle to ellipse means keep x and scale y by b over a. Proof hint. Start from q equals a cosine theta, a sine theta on the auxiliary circle, then project to p equals a cosine theta, b sine theta. Number 12 out of 15. Focal feet on the auxiliary circle. If you drop perpendiculars from the foci to the tangent, those feet land on the auxiliary circle. Proof hint. Use right triangles along the tangent together with the tangent reflection structure. Number 13 out of 15. Director circle. If two tangents from an outside point meet at a right angle, that point lies on x squared plus y squared equals a squared plus b squared. Proof hint. Perpendicular tangents force one clean quadratic relation in x and y. Number 14 out of 15. Conjugate diameter bisects parallel chords. For a family of parallel chords, their midpoints lie on the conjugate diameter. Proof hint. Write the whole chord family through a point on that diameter and watch the two intersection parameters come out symmetric. Number 15 out of 15. Latus rectum. The chord through a focus perpendicular to the major axis has length L1, L2 equals 2b squared over a. Proof hint. Set x equals c in the ellipse equation and solve for the two y values. Now step back. The ellipse is one member of the conic family, and conics were a major theme from Apollonius in Greek geometry, to Kepler's model of planetary motion. Then, Newton's universal gravitational law explained why planets move in elliptical orbits. So, this is not just elegant geometry, it is geometry that reached into physics and astronomy. There are many more wonderful facts about ellipses, but these 15 already take you a long way. Some proofs were hinted at here, and fuller proof videos for several of these facts will come later. If you want those future proofs and more compact decks like this, subscribe and come back for the next one.